Okay, so just to wrap up what we were doing earlier, again, the last thing I did is I asked for a prediction of what the expected score based on my regression model, what the expected score for a school that had 80% of its students on free or reduced price lunch would be, taking the example of Solana Avenue Elementary, and what the model told me is it should be about 750. Solana Avenue Elementary was actually 922. So what does this tell us? It tells us things are going really well there. And obviously this is sort of, I don't know, just handy, I guess. I think that it's handy just to be able to see what's going on. So I am actually going to go ahead and put a dot in a different color. So this is, remember, highlight school was the where I pulled out Solana Avenue Elementary, and I'm actually just, like I said, making a dot in orange at that place. And say color orange, right? And now what I can do is just go ahead and see how it looks. Right, so I could just stop plotting these histograms. Right, so there it is. There's Solana Avenue Elementary School. So again, the point of this is, for the Pioneer Press story, this is how they approached it. Now, there are some things that we are missing here, some elements of our linear regression model that we haven't addressed. And specifically, one of the things that we have not looked at in this is something called the R squared value. Basically, one of the things that we want to know when we do a regression is we want to know how much of the pattern in our data is explained by the variable that we have selected. So while we know that there is a slight negative relationship, in this case, there's a negative relationship between academic performance and the percent of students on free or reduced price lunch, we don't know how much of the variance, right, how much of the spread or of our data, right, is actually explained by that. We know some of it is, but we don't know how much. And so that's actually something that we will look at. We will use stats models for, because that's going to give us a nice printout of all of the things that we can, of how a given, how much a given part of our potential of our model is explained by a given independent variable. Okay, so to do that, we are going to switch over a bit. We're going to actually use a different library. We're going to bring in that stats models library to get some of the more detailed information about that. So in order to get a little bit more information, we are going to actually import a separate library. And that library is called stats models. And that's going to give us some of that information about how influential our chosen independent variable is in terms of predicting behavior. So what we're going to start by is we're going to add a library here, and we're going to say import stat models API as SM. Okay, and I don't want to change around too much stuff here. We can actually keep most of what we have. We're just going to make some additional stuff. It's going to give us what we need to actually use stats models to make this prediction. So what we have here is we've done our whole thing. We fit our linear regression. We've done our scatter plots, et cetera, et cetera. Now what I'm going to do is I'm going to actually stats. I'm going to close this X stats, so I remember that it's different. This is going to be where I take my data frame. And first, and I'm just going to look at my meals. Oops. And my meal values, that's going to be my X stats. My Y stats is going to be basically my achievement values. So very similar to what I did above, but I'm going to keep to that because I'm also going to create this. I'm going to add constants. So this is something that the statsmodels allows us to do, and this has to do with making the prediction line for the intercept, but it has us make comparison more easily when we actually get the model details. So I'm going to add constant, and I'm going to add it to the x value. Okay, so bear with me for a second here. So I'm going to say just basically like prepare the data for stats models. This is not going to be graphical, but it's actually just produce print out the screen to terminal with this nicely format, which I appreciate. And now I'm going to say create the stats models model. And they so call my model. And now we have more distinct control, specifically saying ordinary least squares. Notice that I actually changed the order here. You do y and then x. And again, I basically saying fit a model to it. And this is still a linear regression model, but let's say my predictions. My model predict stats. Okay. Now the reason I'm doing all of this really because I'm printing the model summary. So what I want to know is I want to know not just what is the coefficient, right? The slope of that line. I want to know what's our squared value. I want to know how much of this model, how much of the dependent variables predicted by that particular dependent variable that I've chosen. In this case, it's that I've chosen Niels. Okay, so I can see that there's an effect, but how much of it can actually be attributed to that variable? So fingers crossed we've done everything correctly here. Whoops, I forgot something. Yes. What is the summary of my model? Not any model, my model. Okay, so I'm going to ignore my histogram. I'm going to ignore my graphics for a minute here because what I'm really interested in is this. Okay, so you see I have this very nice, pretty printed table. These are my ordinary least squares regression results. I want to highlight here that the numbers that I see are the same. So because 0 is meaningful value, I point out that our intercept, right, is the same as the constant. So the constant is what is the expected value if our independent variable is 0, not every independent variable can sensibly be 0. So just again, pointing out that these two things match. X1 is, in this case, the first variable, the first independent variable that I fed the model. I only fed it in this case, but I do more. I'm doing a multilinear regression. It's as simple as adding more independent variables to that X stats selection, which is very handy. So what I'm seeing, again, is that these things match. I'm seeing that negative coefficient. Now, the thing that I am curious about here is this, my R-squared value. What this is telling me is that the Mills variable is predicting approximately 28% of the variance in my dependent variable, which is like, okay, not a ton. Basically, what this would say to me, if I was looking at this from my perspective, is I've got about a quarter of the variation I see is attributable to the Mills. That obviously means that about 3/4 of it is not. This is where we start to get into this, like, oh, we can do multiple things. So what if we combine multiple variables? What if we combine multiple variables and try to explain more of the variance in our dependent variable by using 2 or 3 or 4, however many independent variables? So that's actually what we're going to talk about. We're going to go over that in class this coming week, and I'll show you some sort of specific behaviors and some red flags that go with that. But this is just to introduce you to and conducting basic linear regression, understanding how this actually works as a prediction. The prediction can explain because we are because it's a very simple model. We know what literal shape of it is. It is a line. And so it's one of the ones, linear and logistic regression are particularly relevant for actually using to drive stories because it's reasonably, because we can explain, right? We don't have to use the black box algorithms, the predictive kind of neural network, etc. algorithms we can't explain. We don't really tend to use this for journalism in terms of telling stories. We can use them to help identify or filter data, identify filter data that we then work around, but it's much more difficult to use them for actually telling the story itself, if that makes sense. So anyhow, that's all for now. If you want to give this stuff a try, please feel free to make sure that you have the libraries that we are going to need correctly installed, because we will be going through this together in class, and we'll take a look at those multiple linear regressions. So